Hello, everybody. We are starting a new series, Space Science, and we try to explain the technical specifics of the recent advancement on the space science, the mainly the going to Moon and Mars, what kind of technologies are necessary, and that's what we talk about in this series. Today, the first question is, we have Earth and the Moon, and very special characteristic of this Moon is it's facing same side all the time. What it means is when it's moved, over here, this face move facing to Earth, and it's move again, the same side facing to the Earth. So from Earth you can see always the same side of the Moon, and other side, this side, they call sometimes dark side. It's not dark, it's just the far side. It's always away from the Earth, so it's not dark side, because when sun is here, then it's shining. This side is day, moon day, and this is night. So this is a new moon, and you see crescent moon here, and when it's come here, only one side it's get the sunlight, so you see the half moon, but again you see the only same side. Okay, so when you send a rover to the moon and the land on the moon, when sun is here, then the Earth side is going to be night, new moon, and temperature plunge into minus 150 degrees C. Okay, this is because there's no atmosphere. But other side is a full moon, temperature go up to like a 200 roughly. So far the measured data plus 200 degree, so the temperature difference is so great. And electronics parts like IC chip, we use IC chips on electronics control on the rovers and the spaceship. This chip usually go from minus 50 to 120 at most. So this is gonna be out of range, means circuit is gonna freeze at this temperature, and it's baked in this temperature. Okay, the temperature goes up because of sunlight radiation. So you know the heat has three way to dissipate, right? It's the radiation, so direct radiation receiving photon, the lights, intense light, and conduction. Conduction is touching you touch surface by hand, you feel heat, so that's the conduction, right? On the convection is the heat is transferred by the movement of air or liquid, And since there's no atmosphere, this never happened. So when sun shine on the moon surface, sunlight, anything touching is going to be 200. But if you have space shuttle and this side is shadow, so this is going to be minus 150. But the heat come by conduction from here. Heat come from conduction and this heat up. So where this approximately 200 degree come from? 200 degree come from the characteristic of the rocks. When you get the sun's heat, it's heat up and heat up forever all the way to 1000 degree if there's no radiation. This radiation remove the heat, and this radiation increase more at the higher temperature. Around 200 degree, the radiation energy from sun and the radiation energy that escape from rock balance out, so it stay around 200 degree. So that means all the moon surface is radiating light with the 200 degrees, the shiny, and that's the reason moon is shiny. Okay, and you look at the dirt and the rock, the sunlight hit and reflect. How much it reflect? Not much. They are dark color. Okay, so that's not the light we are seeing when we look up the moon. The moon is shiny because of this radiation. It's heat up like you heat up something so hot it start glowing. Okay, so moon grows by sunlight's energy, and that's why moon is shiny. And we are landing on this like seemingly microwave cooking temperature. Okay, and once you have this shelter, inside the shelter there's no sun heat, so the heat escape by conduction unless this contact point is hot. The night, this moon's night, no more radiation, then it's plunged to minus 50. So this is a harsh environment to land. Okay, so going back to this facing same side, there are several issues to land on the moon. You land on the near side. This is near side. Okay, near side, you have a choice. You land during day or full moon is day, new moon is night for the near side. Which temperature is better to land? Okay, most of people choose, most of nations choose the daytime, the hot temperature surface. And the reason is not temperature. The reason is you can communicate to the satellite directly if it's on the near side, because near side always facing Earth, so you have a antenna, and the Earth has an antenna, and you can communicate. Okay, but after going circle, if you land on the far side, then you cannot communicate anymore, right? Because this microwave communication wave goes straight like lights, and there's no way you can reach here. So your satellite is gonna be lost forever. So even when you land on the moon, it's nighttime or daytime. I heard a very funny joke that this is American politician. She advocate that we should go to sun and get the sample and study, so scientists know the secret of sun, then we solve the energy problem. And somebody asked, science so hot, how you can go there and get the sample? Then this politician said, well, how about we go nighttime? So that's a ridiculous. I mean, this politician is like less than 4th grade in elementary school, doing a politician work for us. I mean, just incredible. So moon, you have a choice of going there nighttime or daytime. And nighttime is very cold, and electronic circuit doesn't work. It's very difficult. But daytime, you can contain important electron circuit by sheltering shell, and the shell get hot by sunlight. But contact to the internal circuit from shell can be controlled by heat insulator, so the outside shell heat doesn't go into the electronics board, because if heat goes and temperature goes up to 100 degree, electronics are gonna be baked and no longer work. So it's possible to keep electronic circuit by heat insulator connecting to the shell, and the shell absorb all the sun heat, and the inside can be lower temperature. Well, same thing can be done even you go nighttime, but you need a heater, right? Because the heat dissipate all the way, the outside shell become minus 150 degree. How can you protect the electronic circuit inside? You use a heat insulator. But moon night is long. Moon circle around about 1 month. So it's going to be half a month's day and half a month's night. And even heat insulator, it's leak out heat little by little, and temperature goes low, right? So you need a heater, but the battery doesn't have much energy. It has only energy collected by sunlight. But nighttime, you cannot collect any sunlight. Okay, so when you land on the night, it's tough unless you have like a nuclear battery heaters to heat up inside the shell and survive nighttime. So the moon nighttime is about half month you are survival mode, and when sun come out, then you can collect sunlight by solar cell, the energy battery is charged up, then you can do exploration of the moon. So most of the time they try to land on the daytime, okay? And another consideration is the near side. The reason is you can communicate directly from Earth. When you landed on the far side, then you don't have any communication. But China landed on the far side. How do they communicate? Okay, this explains how. You look at this one. They put some kind of relay satellite behind the moon. Okay, then communication goes relay satellite to the back of the moon, far side of the moon. How can you make this kind of relay staying on the back of the moon? So they called Chang'e 4, the fourth exhibition, the China's fourth exhibition. Before they land on the far side of the moon, they put this communication satellite, and I explained to you how it can be done. Okay, this is Earth, maybe sun here, and the moon. Okay, there is so-called Lagrange point. Lagrange point. Lagrange point. What is Lagrange point? Is there is a stable point in this solar system, and around the Earth there is a one called L1 and L2 and L3. Okay, how they are stable? What do you mean by stable, right? They're stable in a sense that, for example, when you go to the moon, on the way there is a Earth's gravity and moon gravity pull each other. There is the equal point. Okay, and this is not really L1, close to L1, but it's not. If moon gravity and Earth's gravity, let's say Earth's gravity is gravity constant and mass of Earth are distance square, and moon gravity and distance from moon is equal. If they are not moving, this is the correct equation, right? But if moon is going around the Earth, you know there is the acceleration acting on this, right? There's no gravity is gonna fly out what this force, and this conveniently we write this way. This is this different L1, no, L2. Okay. Wait a minute, not L. The what is the best? Moon, Earth to moon, it's circling around, so you have this omega is angular velocity, right? It's a radius. You learn this in the physics. The R M is v. So v square the angular velocity is easier to handle this case. So when you're here, you have this acceleration going around the Earth, and whole thing's going around the Sun. There is another acceleration, right? So in L1 the same thing, but acceleration A1 is this way, so it's gonna be for L1 A1 plus GME RE square equal GMM RM square plus A2, because this is going around the Sun. For L2 point, this goes to this side. Okay, so if you calculate precisely two acceleration due to the circular movement plus this gravity and this gravity, so total gravity for L2 point is going to be gravity from Earth and gravity from Moon and the acceleration, but it's depend on where the Sun is. If Sun is this side, the sign change, this sign changes, right? But the Sun's acceleration, because of the large distance, is much smaller, so we can probably ignore, and we have only acceleration that caused by Moon circling around the Earth. So L2 point has actually Earth's gravity and Moon gravity equals acceleration. That's defined L2 point. Okay, so that the gravity and acceleration is balanced. So if you put satellite here, it's doesn't fly away, but it not attracted by the Moon gravity and Earth gravity together. Okay, so there is a point called Lagrange 2 point. Okay, but if you put the relay satellite here, you cannot communicate, right? So the clever idea came from Chinese this relay satellite. You can orbit around L2 point. It's called halo. It's a vertical orbit with the Earth Moon axis, right? So you can put the communication satellite here. Okay, how does it work? Let's see. This is the L2 point. This has gravity. This has gravity. So if you take a vector, okay, break into two, this red color, break into two. So this component from Earth and the Moon is going to be total gravity toward L2 point. So you have you have a situation as if you have gravity acting toward L2. So this together is going to define the speed of this halo orbit and radius by this gravity. And this force and this force together is going to determine the gravity, total gravity by Earth and the Moon. And that's gonna balance out with this A1 acceleration. So this entire halo orbit is going to balance out by A1, and this component, Earth's gravity with this component and Moon gravity of this component. So together balance out in A1. So this halo orbit is going to move along with Moon in the same speed as the Moon around the Earth. So once you put relay satellite here, you can see the back of the Moon and you can see the Earth. So from this relay satellite, things look like this. You see Earth and you see the Moon. You are here, so you can see both. So even you land on the back of the Moon, you send the data to this satellite, and this satellite send it back to the Earth, or signal come from Earth. This relay satellite is going to relay that signal to the lander and the rover on the back of the Moon. And that's a way it's possible to land on the far side of the Moon, and we can still communicate. Okay, and they did that with Chang'e 4, right? And used the same relay satellite to get the Moon sample on Chang'e 5. And recently China sent a second relay satellite. So they have two relay satellites. This is a preparation for sending a man to the back of the Earth, or maybe near South Pole. So what happened is, it's safer to have two relay satellites in case something go wrong with one. You don't want to get lost with human on the Moon. No communication, that's not good, right? So they send second relay satellite and a little bit different orbit, but still L2 point, so it can see both Moon and Earth. So it does signal relay, and this is a preparation for Chang'e 6. Chang'e 6 is ready to go and collect Moon sample from different locations second time. Okay, so that's how they handle communication with the back of the Moon. The back of the Moon means far side of the Moon, which is never revealed to Earth. Okay, so communication to Earth from the surface of the Moon is not easy, and so far India believe they landed, but communication is not working because it's close to the South Pole. Then there is a ground effect, so they can't communicate. The Japan landed and seemed to be communicating. Depend on location of the Moon. If you land too close to North Pole or South Pole, you cannot directly communicate with. You need to go through satellite around. So that's why China always goes through satellite. The communication link is from satellite, and in this case, the relay satellite at the L2 point orbit. And that's important. When it's go far away, depend on which part of the planet you are, the direct communication is going to be a problem. It's easier and better to use satellite going around the planet as a relay satellite. And that's what China is doing for Mars. And anybody who try to do communication directly on the surface of planet to the Earth is pretty tough to do without a large parabola antenna. Satellite can have a large parabola antenna, but the lander and the rover cannot carry such a big parabola antenna. So the signal is going to be very limited, and communicating directly to Earth is kind of not a good idea. Okay, so that's all for today. The first space science, how to communicate with the far side of the moon. The answer is relay satellite that is orbiting on L2 point, Lagrange 2 point. Okay, so see you for the next subject.